the number of electrons contained in 1 coulomb of charge equals to. So we know the charge on 1 electron is 1.6 into 10 power minus 19 coulomb. Now for 1 coulomb, what will be the number of electrons? So if we see, for 1 electron the charge is 1.6 into 10 power minus 19 coulomb. So for 1 coulomb, how many electrons will be there? That is 1 by 1.6 into 10 power minus 19, and its answer is 6.25 into 10 power 18 electrons. So option B is the answer. The ratio of forces between any two tiny bodies with constant charges in air and in insulating medium of dielectric constant K is. So in the first case we are keeping the charges in air, in the second case we are keeping the charges in the some medium with dielectric constant K. Then we are asked to find what is the ratio of forces. So in the first case, F is equals to K Q1 Q2 by R square. We are substituting the value of K, that is 1 by 4 pi epsilon naught. And if it is F dash, that is the force in certain medium, that is 1 by 4 pi epsilon naught into K, where K is the dielectric constant, Q1 Q2 by R square. So if we are dividing these two, F by F dash, then we have to divide this one also. Okay, so F by F dash will be equals to, so this whole term and this whole term will go, but this K will be left out. Okay, so this is 1 by this 1 by K. F dash for this is 1 by K, so F by F dash will be equals to K. So the answer is K is to 1. The SI unit of free space permittivity epsilon naught is. So we know F is equals to KQ square by R square, and K is 1 by 4 pi epsilon naught. Now we have to find the units of epsilon naught. So 4 and pi are constant, so they don't have units. So epsilon naught equals to Q square by FR square. That is, epsilon naught is proportional to Q square by FR square. What is the unit of Q? That is charge, that is Coulomb square. Unit of force is Newton. Unit of distance is meter square. Sorry, meter, and it is R square. So that means it is meter square. So the answer is equals to Newton power minus 1, meter power minus 2, Coulomb square. So option C is correct. A body has a positive charge of 8 into 10 power minus 19 coulomb. It has. So if it is having a positive charge of some value, then it means it has lost 5 electrons. Okay, so that is the first thing you have to get. So it has lost 5 electrons, so the option can be B or D. Now how much electrons it is losing? So we have the value of Q, right? We have the value of Q, and we also know the value of charge on electron. So we know Q equals to N into E. So from this we can determine what is the value of N, that is Q by E, that is 8 into 10 power minus 19 by E is 1.6 into 10 power minus 19. So this we get, it is 5. So there are 5 electrons deficient. That is the answer. Which one of the following is not a unit of electric field? So they have given 4 options, so we have to find that. So we know electric field is equals to F by Q, that is force by unit charge. So what is the unit of force? That is Newton. What is the unit of charge? That is Coulomb. So it is Newton per Coulomb. So that is the first option, so that is not the correct answer. And if we see B, it is volt per meter. We will see this formula in studying potential. E equals to minus dV by dr, where V is the potential drop and R is the distance. Okay, E is equals to minus dV by dr. So there is a formula like this, and we will study it later. And what is the unit of voltage? It is volt. And what is the unit of distance? That is meter. So volt per meter. And if you see, this volt is also equals to work done per unit charge. Okay, work done by unit charge, this is also called as volt. So what is the formula for work done? That is joule. That is unit of work done is joule. It is work done per unit charge, that is joule by coulomb, that is also equals to volt only. So joule per coulomb per meter, so that is also another unit of electric field. So the odd option is joule per coulomb. So joule per coulomb, that is itself volt. Okay, please try to understand. Joule per coulomb, that is work done per unit charge, that is itself volt. Okay, so that cannot be a unit of electric field. The figure shows electric lines of force emerging from a charged body. If electric fields at A and B are EA and EB respectively, and the distance between them is R, then So this is the electric field lines they have shown, and it is denser at A and it is rarer at B. Okay, the electric field lines are very densely packed in A, while it is some far apart in B. So A electric field at A is greater than electric field at B. A proton and an electron are located in a uniform electric field. They will experience. So a proton and electron are located in uniform electric field, and they are asking us the force experienced. So let us see the answer. Equal forces in same direction. That is not true because electron is negative charge and proton is positively charged. So their force, the direction of force will be in the opposite direction. For proton it will be along the direction of electric field. For electron it is in the opposite direction of electric field. So that is the wrong option. Force is equal in magnitude. So that is true. Okay, let us check for other options also. Equal accelerations in opposite direction. Do they have equal acceleration? We know acceleration equals to QE by M. So the electric field is same, the charge is same. The electric field is same and the charge is same, but the mass of electron and proton are not equal. So the acceleration will not be equal. Okay, so this option is wrong. So acceleration is equal in magnitude. That is also wrong because the magnitude of acceleration is different. The electric field intensity at a larger distance x from an electric dipole is proportional to. So we have seen it already. The electric field strength is proportional to the distance, that is cube of distance. It is inversely proportional to cube of distance, that is 1 by r cube. So that is the answer. A charge placed at a distance from the electric dipole in an end-on position experiences a force F. If distance be doubled, then the force will become. So end-on position is nothing but axial position. Please that a circle is placed at a distance of a end-on position. So if the distance is doubled, the force will become. So let us see the answer. So we know the general formula for electric field at axial position due to a dipole is 2 kp by r cube. Okay, so it is inversely proportional to r cube. That is what we have to note. E is inversely proportional to r cube. So what is the force on the charge? So F is equals to Q into E. So here E is proportional to 1 by r cube. So instead of E, I am writing 1 by r cube. So F is directly proportional to Q by r cube. So this is the general case. So now what we are doing, we are doubling the distance, that is r is doubled. So F dash is equals to Q by 2r whole cube. We have to take the new distance, that is 2r. So 2r whole cube. So F dash is proportional to Q by 8 into r cube because 2 cube is 8. Now let us divide F dash by F. So this by this. Okay, so it is 1 by 8 by 1 only. So 1 by 8, yes, F dash by F equals to 1 by 8. So F dash equals to sorry, I have made a mistake. F is equals to 8 into F dash. So F dash will be equals to F by 8. So answer is option D. A dipole placed in uniform electric field with a dipole moment parallel to the field it experiences. So if it is parallel to the field, then theta equals to 0. So there will not be any torque. Okay, and what about the force? If it is uniform electric field, then there will not be any force also. So it experiences no torque and no force. An electric dipole of moment P placed in uniform electric field E experiences a torque which is, it is P bar cross E bar. Okay, then only it can be P E sin theta. So it is P bar cross E bar. So yes, that is the answer.